Hello, my name is Karthikeyan A11 and my metric card number is 01DE25F1008.
Hello, my name is Vishal Ratnam. My matrix card number is 01DE25F1021.
Hello guys, my name is Abhimanyu Nandan. My matrix card number is 01DEE25F1019.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adik Raika bin Zulkarnain. My matrix number is 01DEE25F1005.
So hello everyone, today I'll be presenting on the applications of vector in 3D space. So first of all, vectors plays a very important role in mathematics, physics and engineering because they help us represent quantities that have both magnitudes and direction, such as force, velocity and displacement. So furthermore, in three-dimensional 3D space, vectors are used to describe and solve problems that occur in the real world. For example, calculating the direction of an aeroplane's flight path, the force acting on a structure, or even the lightning and movement in computer graphics and game design. Last but not least, in short, vectors allows us to understand and visualize how objects move and interact in space.
By the end of this presentation, you should be able to understand what a vector in 3D space represents. Secondly, identify real-life application of 3D vectors. Third, solve problems involving a scalar dot and vector cross product of vectors in 3D. Lastly, apply vector concept to find the angle between two vectors or the area of geometric figures.
So today I'm going to be talking about a daily life example of an airplane flying against the wind. So the scenario is an aeroplane is flying with an air velocity of v1 equals to 400 plus 50 j plus 20 km per hour, where I represents the east direction, j represents the north direction, and k represents the upward vertical direction. A wind is blowing at v2 equals to negative 60 I plus 30 j plus 0 km per hour. You are asked to determine the resultant velocity of the plane relative to the ground, and the angle between the airplane's velocity and the wind direction. So this is the example diagram given of the airplane velocity, the wind velocity, and also the resultant velocity. To find the first question, we have to find the resultant velocity. So the resultant velocity formula is Vr equals to V1 plus V2. Vr is equivalent to 400 minus 60I plus 50 plus 30J plus 20 plus 0K. So the Vr is equivalent to 340I plus 80J plus 20K km per hour. Now that we know that the Vr, now we have to find for the magnitude of the resultant velocity. So Vr equivalent to cube root 3402 square plus 802 square plus 202 square. Once we have plussed all that, we have to times it with the cube root. Now the final answer for the Vr is 350 km per hour. Now, to find the angle between the airplane velocity and the wind direction, there are a few components that we have to solve first before we get the final answer. So first, we have to use the cos formula. Cos theta equals to V1 dot V2 over V1 times V2. So V1 dot V2 is equivalent to 400 times negative 60 plus 50 times 30 plus 20 times 0. So the final answer is 22,500. Now to find the magnitude of V1 equivalent to the cube root of 4002 square plus 502 square plus 202 square is equivalent to 403.6 for V1. Now to find for V2, V2 is cube root to the bracket of negative 60 times 2 to the power of 2 plus 300 2 to the power of 2 plus 0 to the power of 2, and the final answer is 67.1. Once we have gotten our V1, V2 and V1.V2, we have to substitute them into back the formula and get the final answer. Now to substitute back inside, we are going to use back the cos formula again. So the final answer for this after substituting all and dividing them is negative 0.831. Now then you have to convert the cos into cos to the power of negative 1 and get the degree for theta. So theta is equivalent to 146 degree.
Conclude, vector in 3D space are powerful mathematical tools that help us describe direction and magnitude accurately. By using vector operations such as a dot product and cross product, we can solve real-world problems involving force, motion, and geometry. Understanding vector in 3D not only strengthens our mathematical foundation but also prepares us for practical application in engineering, physics, and technology. Thank you for watching my presentation.